Okay, so in this module, we start working with pointers and references to variables in C++. And we'll go through their basic usage and how they allow to give low-level access in memory. Obviously, having low-level access is kind of a double-edged sword. It can allow for very efficient use of the memory, but also can allow for very difficult mistakes that is very hard to track down and debug. This is why this is the type of functionality that in a language like Python are carefully disallowed. But on the flip side, that leads to inefficiency in the implementation. So let's look at the basics of how things are defined and how they work in the internal memory. So we have to think about a model where memory it's like a long array of bytes that is used to store data values of different that use a different number of bytes. So here, for example, we have a declaration of an integer with a definition and a value assigned to 0, int a. And so we really have to think that there is some location in memory that takes 4 bytes in storage as an int, and in this case would have 0, 0, 0, 0 as values, and any instruction that manipulate that has to kind of know what is the location of the data. So in particular, this notation of ampersand a denotes the address, so allow to retrieve the address where the variable a is stored. So that's what we call this kind of reference to a. And so that there are variables that can store this type of addresses. For example, int star, it's not an integer, but is a pointer to an integer. So it is the address of some integer. So for example, we could assign to b the address of a. And so while a is an integer, b would be the pointer to that particular integer. Once we have the pointer, then we can do manipulation of values. So if I do star b, it means I'm using the dereference operator. Notice the difference when it's a declaration of a variable versus when you're using an expression. So that means instead of working with b, we work with the object pointed by b. Since b is a pointer to an integer, star b is an integer, so we can assign 10 to the location of the variable pointed by b. Another way to reference into object is directly do the declaration of with the ampersand. So if I do integer ampersand RA, which is kind of, we use it to imply the address of A. And so in this case, RA and A refer to the same location. Effectively in memory, this is going to be implemented as a pointer, but these get differences all the time. So we can use directly RA as equivalent to A. So as we go through this, in general, let's look at a few examples so that we can map the memory and get a practical indication of what's going on. So this is a very simple piece of code. We declare a variable a of value 0. So this means that in the stack, in this portion of memory, we have a sequence of location. So in this column, we have the addresses of the locations, 0, 5, 9, 1, 5, 9. So since each of those take 4 bytes to store, we skip the 3 in between. So we go 1, 5, 9, and so on. So D, again, because we're using hexadecimal. So A is assigned 0. So the 4 bytes starting at 1 have all assigned 0. And now we declare a variable that is a pointer to an integer. So the variable itself, if we are on a 32-bit machine, the pointer will take 4 bytes. So the the size of this still goes from 5 to 9. And now the value stored is the location of A, and A is stored in location 0001. So we have this pointer that goes from this through his location to the location of A. So now how that can be used? Here I can say object pointed from B is get assigned the value 10, right? So P points to an integer, B points to an integer. So we're referring to location that is also A. So after the execution of this statement, A and star B, they both have value 10. Again, because B points to the location of A. So this is an indirect way of modifying the value of A. So as you can see, although it could be convenient, this could be really hard to debug because we start having modification of the value of A, even if A is not really involved in this in the computation of this expression. Moving forward, and then we can declare a new variable. This is another pointer to integer. And now we assign the pointer the same value B. Since B is of the same type, they're both int star, they're both pointers. So they both have value 0001. So they both point to the location in memory of A. And so as we look at this, then we can declare a new variable. Here it's D. And now what we can do is we could reassign B as the address of D. So B is the address of D. So then before we used to have the so B and C were pointing to the same location. Now B has been redirected to point to the location of D. And so here you can see how we can have this manipulation of pointers. And so while, for example, this instruction star B equal 10 executed at this point would mean to A become 10. If I were to execute that instruction again after this, because B now points to the location of D, this would become 10. Again, there are efficiency reasons to use this type of notation, but as you can see, the code can get really complicated, very hard to analyze and debug. So it's important to know how those things work. We will ask questions during the midterm, but at the same time, one has to be conscious that this has to be used with very, very much caution. So let's look at more examples just to get a practical sense how those things work. So let's say that now we allocate a space for an integer A with value 5, and then we create a pointer to that integer. So the value is 001 of the pointer. That it goes to the address of A. Now you can see how those things can layer on top of each other. And so we can define a variable that is the pointer to a pointer to an integer. So here we have the star twice. And so this variable points to something like B. B is a pointer to an integer. And so C points to that. So the address of B is 005. And so this is stored in C. And so we would have to dereference twice to get to the value of A. Now we create a new variable, D of value 7. And now we can dereference star C, so which then it goes really to B as a pointer. So B used to point to A, so address A, And instead now B, which is pointed by star C, gets the address of D. And so here you see the address here assigned to the pointer value. So generally speaking, so this is how we want to think about pointers versus references. So the references can automatically be referenced, then we'll see even more. So if I create a variable B that is referenced to A, the ref B will be used basically as an alias of A, although it's be stored in a pointer and go and refer to A. So we can refer either to A or to B, and that's the same location in memory. So reference cannot be reassigned, while when we have pointers, as we saw before, they can be reassigned. So in this case, when I have int A and int ampersand B, A and B refer to the same location in memory for all practical purposes. So it cannot be used in a different way as an integer variable. A couple of points looking at the memory location to have a better intuition of what's going on at the byte by byte level. So let's say that we have an integer num that for which we assign the value 100. So this means that we have reserved this location. So before we were showing at a high level the 4 consecutive addresses were assigned to that integer. Now we're expressing this actually showing the location 123, 24, 25, and 26. And then the 4 bytes that store the value 100. When we allocate the pointer int star to the address of num, here we will have the value of the address, which is 123 here, stored in the 4 bytes. So the so here we're talking about 32-bit architecture, and this 4 bytes store the address on the number itself. So let's look at how that would be on a 64-bit architectures, exact same code. So we create the integer. So integer still is not a long, so it will still take 4 bytes. So value 100. But now the address of num, it will be stored in 8 bytes instead of 4 because it's a 64-bit architecture, so the pointers take more space. And so the value 123 it gets stored as a long integer. It's really a pointer, but it's 123 stored across 8 bytes instead of 4. So let's look at a couple of more examples just to see how things work. Some examples are slightly more complex. We'll keep the 32-bit case, just otherwise it gets too long and complicated, but the concepts are all the same. So if int num is 100, int star, the pointer to the number is 123. And now if we do instant star, so the pointer to the pointer is the address of num pointer. So this would be the new variable, 4 bytes. The value stored by this variable would be the address of the previous one. So we have 127, obviously taking the 4 bytes. Now let's look at something a little bit more interesting. We have an integer num 100, num2 200. And we are assuming that num2 is stored at address 150, so it's kind of farther down. So as usual, int star num pointer ampersand num initially is the value 123. Now we can assign the pointer to the address of the second variable. It's the address of num2. If that was stored at address 150, So here we get 150 again divided in the 4 bytes. So we get the assignment and we get the address. So even if the value is 200, the address is 150. That's what we get stored in the pointer. So additional case, integer num 100. Now we look at the address assigned to num pointer. So it's ampersand num. And so here we see the address stored here. So here with the reference, so the reference operator, we can do star calculation. So minus equal is decrementing the value by 1. So the object pointed by num pointer gets decreased by 1 as an integer. So here is 123. The 123 is here. We look at this location. Initially value was 100, so it has to be decremented by 1, and we get effectively 99. An additional case where we're starting mixing pointers of different types. So one has to remember always that while the variable type imply different number of bytes in terms of storage allocated, the pointers themselves are always of the same size because they all refer to addresses of a particular location. So here, if you do num 100 pointer to the address 123 as usual, then we create a character which take a single byte. So look here, and then we create another pointer. So what value is being located attached here? Num pointer 2 is equal to num pointer plus 1. Now in pointer arithmetic, the addition plus 1 and minus 1, it's always assuming the entire size of the object. So here the integer takes 4 bytes. And so when we do the addition, so 123 plus 1 means one entire integer location. So it goes to 127. So this pointer to an integer, it gets the location of this address because we add the size of one integer to 123. And so 123 plus 4, 127. One more example. So let's say that we have an integer of value 100. As usual, we create a pointer to its address, so the value is 123. We create a character A, so that's the location 131 here. Now we create a pointer to a character, and we take the value of the address of temp plus 2. So where is this going to locate it, and what is the value that is going to be associated? So here, being a pointer to a character, so the size is not 1 byte, it's still 4. The character takes 1, but the pointer takes 4 location. But then when we add the 2, each time we add 1, because a character takes 1 byte location, it really adds 1. So 131 plus 2, it gets 133. If it was integer, we would have added 8, but being a character, we added only 2. So to summarize, we look at how those things are written in reference. So it's important to keep track of those. Again, remember this will be used in the midterm. So variables can be described in a simple way. This allocates some memory. Then we have pointers to those locations. And then we can take the address of a variable and assign it to a pointer. We can also make directly a reference so that instead of playing with the pointer that could even be changing, we can just use the new number. So using numref or num is exactly the same. If I do numref equal num2 is the same as saying num equal num2. So if we do numref if equal to the address of num2, this will not work because again, numref will go work with an integer, not so it's not possible to get to use that for a reference. So more examples. So we have a number 100, the pointer to the number, reference to that number. And so here we can then start combining the variable int star with the address to a, so this is kind of the address to a pointer to an integers. So this is a reference to an int star. So we use it directly as if it's a pointer to an integer, although it's used as if it was a pointer to an integer. And so this can be used obviously to print the values, and so numref can be decremented the same as decrementing the number itself. Again, here we are having this numref will ref to the same as num, and then num pointer reference. Again, we are looking at manipulating the pointer, and so and then we do the dereferencing of that, and so incrementing by 1 is the same as incrementing by 1